Hey, welcome back to the stream. This is going to be kind of a weirdly early one. I think I kept waiting for it to feel like a good time to start, but I think I'm just going to go for it. It's going to be kind of a meandering Rust programming, co-working, hangout kind of thing. I think Tuco might be hanging out with us too. Looks like we are live on YouTube on the Scanlime-in-progress channel, as well as on twitch.tv/scanlime and live.diode.zone/scanlime. Good morning. Well, it's morning here. I'm sure a lot of you are tuning in at different times. What is that in the corner? Oh, that's not supposed to be there. Clearly I didn't actually get all the cameras adjusted properly before starting the stream. It's okay, you can watch me fuss with the cameras. Gotta get the right view of the cat here. Well, I think I know where to put an auxiliary camera. Yeah, I'll have to think about where to put a camera to get the best view of Tuco if he's gonna be hanging out under there. I keep going back and forth with him, like making changes to the environment and trying to figure out what he wants. And this little heating pad under the slightly different tall desk thing in here is a bit of a recent change. Seemed like he would enjoy it though. Aw, that's better. Hey, honey. He's a sweet cat. Ears. Well, maybe he can hang out in the corner of the stream, or the screen while we do the computering. Oh gosh, I'm so sorry, Vince, to hear about his cat passing away. Gosh, I wonder if there's a way to get the camera temporarily lower than this. It's on this tripod at a great height for doing desk photography stuff, but Tuco being under the desk kind of demands a different camera setup. This is also like the least ergonomic place for the mouse. I don't really know what's going to happen there. Anyway, the project here is still this sandbox thing that I've been building in Rust. The main thing I want it for in the short term is as a kind of easy way to run FFmpeg as a subprocess in Rust with a little bit more of a security boundary, but also with the convenience of having like versioned containers that I can run specific builds of FFmpeg out of. So I've been mostly running like simple stuff like BusyBox shell and stuff. I started to get a little further at running the actual FFmpeg binary. Oh, so yeah, more test cases. Yeah, I started getting a little excited by getting some progress running FFmpeg. Is that what this is? No, this is just running the Ubuntu dynamic linker. Yeah, so I still have to specify the dynamic linker explicitly. I think that might be the next thing I'm fixing. I stuck that in the title in the stream. That's the elf interpreter. So I think I've got a lot of the individual bits and pieces that were breaking in running dynamically linked binaries kind of under control. The most recent thing I had to fix was to do a bunch of infrastructure to get fstat working so that I can take a file descriptor and get the file system metadata associated with that file descriptor. And there were a bunch of reasons why that was kind of hard and weird in this system, but I've got that at least like a first pass of implementation done, and so that gets things much further. If I run FFmpeg right now, this signal 31 is actually indicating that it's a system call that I have not allowed with setcomp. This is just like one way that I'm filtering out system calls. So the system call number is in original AX. So what is OXCC? You can look that up in the system call table. This is what FFmpeg is getting to before the current crash. So I think it's like something inter-process communication related. So yeah, scheduler get affinity. So not a difficult thing to emulate in the system call emulator, but these do have to be traced because they deal with process IDs. So that's something to add. I was also curious if I got any further running just like regular glibc dynamically linked binaries from Ubuntu. Oh, also, before I leave FFmpeg, just take a look at how many memory maps there are. So this did seem to get basically the whole way through the dynamic linker as far as I can tell. Like this crash seems like something that we would be getting during initializing libpthread. So presumably we have libpthread and we're making function calls in it. This isn't a function call into a bad pointer or something, so it's probably not, like we're probably past the point where dynamic linker problems would be showing up. And then if you look down here at the maps dump, this is the original binary that my loader loaded. So this is the actual elf interpreter, in this case libldmuscle. But then all these other addresses are they look like dynamic libraries. I mean, I haven't looked up what these are actually pointing to, but these appear to be kind of elf binary shaped, like they have, you know, execute and read-only and read-write sections that are mapped kind of sequentially in the file. They all come from different files. So this looks like we are dynamically linked at this point. So that's pretty cool. So yeah, then if I try, what was I doing here? Ubuntu. Oh, what was this crash? So this was just trying to run. This is just running the dynamic linker on Ubuntu, so not even trying to run an application, but just trying to get like the error screen on the dynamic linker. And this was weird. We're getting another one of these signal 31s, which is the, what is it, sig trap or something like that. It's not sig trap. Sig sys, that's right. Sig trap is like what you usually get for like breakpoints and stuff, but this one is specifically for system call emulation purposes. And so I'm just using it right now as a signal that I want to do like a debug dump of the process and get like all this info when something breaks. I'm not making FFmpeg on Windows, sorry. This is an extremely Linux project. I'm not going to make a guide on how to compile FFmpeg. There are already plenty of those. If you want to build it on Windows, it might be easier to build it on WSL unless you actually specifically want like hardware acceleration support. If you do want hardware acceleration support, it's a pain in the butt to build it on whatever platform because there are just a boatload of dependencies you'll need. So, like, yeah, find someone else's guide. There's already a bunch of these. This is a good question about what it means when I say a system call has to be traced. Yeah, so I guess what I mean specifically is that I'm using ptrace to get a notification on a different process when one of these system calls is invoked. So I'm using setcomp to load a very small, very simple program into the kernel. And when I say program, it's a very sort of restricted, like domain-specific language kind of thing that's not even fully Turing complete, that's just used for describing filters that let you kind of sort system calls into different outcomes. So one of these outcomes is that you can have the process stopped with a tracer notified. So that only works if you've got what's effectively a debugger attached to this process, so a different process using ptrace. And so I'm not doing this for every system call. I'm doing this for a lot of them, but there's also a whole set of fast path system calls for things like read and write on already opened file descriptors that will just go straight to the real kernel. And so most of these system calls that I say I'm tracing, what I'm doing is I've set up my setcomp filters so that those system calls cause a ptrace trap instead of one of the other outcomes, like going straight through to the host kernel or being completely disallowed or causing this sig sys to be delivered. So that's set up with the setcomp filter. And then in the ptracer, once it actually gets notified that the process is stopped on one of these system calls that I need special action on, then the action really depends on the system call. So some things I'm having to implement in a completely different way. So the implementation for exec, for example, doesn't use the real exec at all. The real exec is not ever invoked because there's no way to invoke it like safely with any sort of string parameter. Like the string parameter could always be a path that ends up escalating privileges outside the sandbox. So exec, for example, will always turn into other things like mmap and read and lots and lots of p-reads and p-writes to move data around, things like that. And then other calls are much simpler, like close. We'll just do a little bit of bookkeeping so that we know that the file descriptor is closed, and then it'll pass that on to the real kernel's close. Open will never turn into a real open for that same string issue where there's no safe way to pass a path into the real kernel, but the open will end up getting traced and turned into a bunch of other things, but primarily a receive message that ends up receiving a file descriptor from a different process. There's a question about what I'm using FFmpeg for. Yeah, mostly for transcoding and various like media segmentation and format conversion and whatever, but this is for kind of a larger project at making decentralizable video infrastructure, and I had been hacking on a kind of streaming video server project, And one of the architectural ideas I was experimenting with was creating these transcode pipelines based on FFmpeg subprocesses, both to allow very tight version control over those media pipelines so that you could produce reproducible outputs, but also to add an extra layer of security isolation and also just for convenience. So there are other alternatives to do this, like I could have used GStreamer. Lots of GStreamer devs are apparently searching on Twitter for people talking about GStreamer, and then they tell me to use GStreamer instead of FFmpeg. But like, sure, I could use GStreamer, but mostly I just want something I can run in a sub-process, so I'm not extremely interested in linking directly with media codecs right now. GZB is wondering if I have to pay an MP4 license fee if you convert to MP4 or downscale it using FFmpeg. I don't think there's an MP4 license fee. Do you mean like the codec licensing? I think that would depend on like specifically what you're doing with the media, but I think there's some exemption for the like the main use cases of like encoding H.264 video and distributing it on the internet. There's some like major exemption that the patent currently allows right now. But yeah, there's legal issues around codecs are always a little bit weird, but the things that people are currently doing on the internet seem to be like mostly allowed due to some like leniency that got introduced into H.264 like around the time that folks were kind of fighting over what codecs were going to be standardized in the browser. And yeah, it's like one of those situations where we could have ended up like throwing out the patent encumbered formats and switching to something less encumbered, but because the patent encumbered format kind of became free enough for most people, then that's what we're using. All right, so this is interesting. I was going to look up that system call. Yeah, so I looked that up over here, 41. I think that was socket. And that was confusing me. Why are we hitting socket? So that's interesting. I might want to debug where that's coming from, because I did not expect that. Not like we could look up what that IP is in. Looks like this library, which is probably libc. Or that could be the application. Anyway, if I wanted to debug this right now, I'd probably want to go invoke this again and try to match up which of these mappings or which file, and then figure out what that address is. At some point, I might want to make some tools to automate some of these. It's like hard to know what kinds of debugging functionality is effectively temporary right now and what I want to kind of keep built into this system for later. Yeah, I guess Walrus already answered this, but Zarthus had an interesting question. They're wondering if there's a future where this abstraction layer is used as a reverse engineering tool for like trapping system calls and creating a map of what the program is doing based on what. And yeah, as Walrus points out, there's already a program that's designed for pretty much exactly that uses the same mechanism called strace. I was joking kind of to myself and maybe on Twitter earlier that earlier versions of this project were basically like a very crappy version of strace written in Rust, because that's what it was basically doing at first. But yeah, I mean, there's an interesting point buried in there, which is that like emulation and introspection tools of all sorts are often quite useful for reverse engineering. I don't know if you'd want to start with something like this, because this is designed for somewhat different goals, but like you certainly could use this if you had something where this was already part of the system for some reason or whatever. But yeah, strace is good if you want a tool that does that with system calls. I think it's also possible to do a lot of instrumentation these days with QEMU on a per process or whole system basis. And you can use that in a variety of environments. Anyway, so there's a bunch of stuff we could debug. I think I might try to keep my eye on one thing at the moment and just try to get the interpreter, like the elf interpreter loading implemented in the kernel, so that at least there's one fewer thing to have to manually do, and one more thing we can just have done and get in test cases and stuff. I'm kind of curious if I can get this to load anything else, or if it's always going to hit that same socket problem. Just trying to open --help as a shared object now. That's ls, also hitting a SIG31. This is a different syscall, 111 hex. Set robust list. I forget what that's about. Oh, it's for futexes. That's interesting. Set robust list might be able to pass through to the host kernel if this has no PIDs in it. Like futexes in general, I would really like to be 100% pass-through for performance reasons. See, and I could also do something in there's a limited amount of stuff that you can do inside the setcomp system call filter, but one thing you could do is like make numerical comparisons on system call arguments. So for example, maybe I want get robust list 0 to be a pass-through, but other get robust lists to fail or to be emulated. We've got just like the tiniest view of Tuco over there. It's like tempting to just lean the tripod over. I don't think I can do that. Wiring situation is too complicated with this camera already. If only I had some kind of flying robot. That's not a bad view. Thumb cam. There's a question about why I'm not using Mac OS anymore on the coding streams. I don't know. I just needed to reinstall this machine, and I was annoyed at Mac OS, and so I put Ubuntu on it, and it's been fine. I always find questions about what OS I'm using to be kind of weird because, like, I pretty much always am using all of the OSs. It's just a question of, like, what I'm using for a particular thing. There wasn't a whole lot that I ended up finding I liked, like OS X for in the previous setup. It was mostly just getting in the way, and I was mostly just wanting to run Linux VMs efficiently on everything. I guess that was part of it, is I got, what was it? I was tired of paying VMware for upgrading Fusion. Like, I wanted something that runs VMs really well, and like VMware Fusion on the Mac Mini was starting to be kind of just not as nice as running like libvirt on Ubuntu. So I feel like making that switch was pretty nice. All right. I'm going to do this pt-interp section. I was trying to figure out if I needed to implement support for atexecfd. So interp is weird. So like when your program has one of these interp sections, the kernel mostly ignores the contents of your program and switches over to loading that interpreter instead. So I think that's mostly what we're doing. The interpreter, once it's loaded, has a couple of ways to figure out what the actual program you wanted was. So as we were just doing, if you run the interpreter directly, by convention, you can specify on the command line what program you want to run. So that's what we've been doing so far. But the way the kernel usually does that is via one of these auxiliary vectors. This is the get_aux_val man page. So as far as I can tell, the only place we use execfd, so passing an open file descriptor into the interpreter, is in MISC binary format support. I'll go through that in the kernel source code in a sec, but it doesn't seem to be the normal case. Normally it seems like we're just using this exec file name string, which I already have support for, so that should be all right. I think I already had a test case for listing out the aux vals. Yeah. Let's do that again. Okay, so there's the LDSO. This is interesting. This is the same LDSO I was trying to run before. Is this the one that was giving me the socket error? Looks like it. Or no, that was some other error, but still. That's ls. Does this work without the binary on the path? That's pretty weird. I guess it might just be an issue of different command line strings getting built. This container might have a entry point set. Ah, this is doing so much dynamic linking. Look at that, libdl. libpcre. libc. Hmm. That's pretty weird. So it's like interesting that this is calling socket at all, but it's also interesting that I've got these two very similar invocations and one of them is working and one of them isn't. That's the one that was working. And that gives me sig31. Okay. Let's look at the arguments. Oops. Oh, yeah. Where is that bin bash coming from? I think that's just the... Yeah, okay, so that looks correct. That's just a little bit confusing because of how the container parameters are set up. So Docker containers have like args and an entry point. If you set the entry point, that doesn't touch the args. In this case, the args already had bash in them from the container. So this is correct. I just had to actually work through it to convince myself it was correct. And then something, so we're getting further in here than we were here, and something leading up to invoking bash is giving us that socket syscall. So if we wanted to figure out where that was actually coming from, that would be maybe cool. It's also much easier to debug this part if we actually made a repro case with some symbols. That's also interesting. Was this... No. Okay, let's just see if we can reproduce that running strace outside of all this mess. So here's some of the stuff we were seeing before. So we'll see it opening libdl, libc, doing some memory mapping, doing some memory allocation, opening locales. I wonder if this is some kind of inter-process communication related to like caching in libc. So here's something socket related. Is this a name server thing? Yeah, I could look closer into what this is, but it seems like we could probably reasonably just have socket always return like enosys or something. My intention is not to support networking at all. It's just that it's initializing what appears to be something related to domain lookups pretty early in the library init. Actually, maybe this isn't even a library thing. Like, do you think bash is specifically initializing something that does a domain lookup? Maybe we can find that in the glibc source. Is this a background thread that... Oh. It's also quite possible that I want to allow domain sockets even if networking in general is not allowed. I also have not implemented the setTID address yet. I'm getting that system call and just ignoring it. I mean, so far I am not actually running multiple threads yet, but I definitely intend to run multiple threads. I don't know, what distros do I use? I've been mostly using Ubuntu and Debian. I feel like I've kind of favored Debian-flavored distros for a long time, but you know, occasionally I'll install CentOS or something. Microsoft Linux is pretty alright. Oh, why is glibc so complicated? I mean, I'm sure they want like efficient, multi-threaded, consistent database functionality for all of this, but it's certainly more complicated than other libcs. Yeah, I don't know why people care about distros. Just use multiple distros. Everything sucks, and you should avoid getting too stuck in any particular thing in general. Yeah, WSL2 is interesting. I've been using that, and it's nice that it is basically just a regular Linux kernel and behaves like a regular Linux kernel. Platypus is wondering if Unix machines are built like a network internally. Not really. I mean, there's a lot of stuff that uses like inter-process communication, and some of those mechanisms, like domain sockets, are part of the networking subsystem, so that like might be what I ended up hitting, but it's certainly possible to have a Unix machine without networking. Is this a separate... like, who calls this? This is definitely a separate program. So we were not running this yet. Like, presumably there's some library code that tries to connect to this, and if it doesn't get a connection, it either starts one or does without, and so like we're looking at the wrong side of this. And a CD client. Okay, so is this called inside of routines like get PW? Let's look at how getPW works. Cool, so there's a shared memory mapped cache, and then there's a socket. That looks like if the socket fails, then it remembers and behaves reasonably. I know I said it was going to work on interp, but this is just so interesting. Anyway, I think I will actually come back to that. It looks like we can stub out socket in some way, and that'll still work, but I think it is worth actually doing interp first. So let's do that. I might actually make some coffee because I think I heard the hot water machine finish its thing. I'm going to put this screen on Tuco, but it's possible he will come with me. But I'll be back in a sec. Oh, Tuco's still here. Impressive. Oh, yeah, that's a good point from Walrus, that there are some kind of more research-oriented operating systems that are more like they have a network internally. They're also, this is also kind of reminding me of one thing that's kind of interesting about Mac OS. Well, actually, Mac OS and Windows both use a lot of like remote procedure calls at somewhat low levels. Like Mac OS has its mock RPCs, which are used all over the kind of low-level parts of user space and for user-to-kernel communication. And then there are lots of RPC systems in Windows, like various kinds of COM, DCOM, that are used, again, at kind of the low-level user space parts of it. Not so much in the kernel. Tuco. Well, what are we looking at? Oh, it's so hard to actually get him on the screen now. Keeps moving. Is that better? Tuco, why are you so blurry? You want the coldness. Oh, the coldness. Yeah, good morning, folks. Just having a kind of chill coding stream here today. Coding in Cat. Hanging out with Rust and operating systems, and yeah, maybe that would be maybe this would be a good like general kind of time to chat about operating systems. Like it's more interesting to me to talk about like the differences between like what makes all the different OSs go than just like, oh, what's your favorite distro? But you know, we could start with that. Like some of the distros have interesting like design choices. Like there's some kind of interesting like NixOS is kind of interesting, right? Like doing a completely new like file system concept based on reproducible builds, but I haven't really played with that. Seems like an interesting idea. But yeah, I've mostly been installing Debian variants on my physical machines lately. I think Tuco is cold now, and he just wants to hang out down here. Desk objects. Oh. He's under there somewhere. All right, let's do the interp section. So let's get back to bandsocks. One thing I was already thinking about is where am I going to store the name of the interpreter? Like, I think I'm going to have to copy the interp string from the actual program header table to somewhere else, like maybe on the stack. Okay, where do we actually start in this loader? What's public in here? Why isn't this at the top of the file? Like all this private junk, and the one public entry point is just hidden in there somewhere. Oh, there's 2 public entry points. Neither of these should be hidden. Okay, we have detect and load. Great. So detect, detects, and load, loads. Detect is synchronous, load is asynchronous. Just like in the Linux kernel, this gets a fixed size buffer of data from the beginning of the file and uses that to figure out if it's a supported binary, probably. That's the layer at which we would add things like support for invoking shell scripts directly. So I've actually already got an empty script binary format for that specifically. Doesn't do anything yet. So then load, we have to find the elf header. So this is actually, yeah, this is actually locating the elf header from the existing already loaded buffer. So this isn't actually doing much work. Then load adder, this is a, I keep wanting to call it an object because I guess my brain is still wired to think about things in an object-oriented way, but it's like a collection of functionality related to having, like deciding where to load a binary and how to represent that address. And kind of deals with some of the subtleties in loading position-independent code correctly. So eHeader adder, interp adder, load offset. This is already kind of letting us know that there's an assumption at this point that this header is the header of the interpreter, and the interpreter is loaded at that address. Which is true if we're running the interpreter directly, but like I think everything after just looking at the initial header here is going to want to operate on the interp and not on the initial binary. So before even running this load segment, so we're going to have to scan the segment table again to look for the interpreter, I think. I just want a better view of the cat now. I can kind of lean this whole tripod dolly over a bit. It's interesting. Gosh, Tuco. That's not great. Re-implementing Linux and Rust. Only small parts of it, but yeah, basically. This replace maps is where I do most of the memory reallocation, And if I'm making a copy of the interp string, I need to think about where it lives. I don't like having to scan the program headers multiple times, but I'm not sure there's actually a downside at this point. Like if I were doing everything in the order it's specified in the file, I would wait until load segments, I would map everything, and then get to the very end and be like, oh, actually there's an interpreter. Let's do it all again. And then load the interpreter. That honestly might be alright. I mean, we already have code to unmap everything. So like the extra mappings wouldn't really be a big deal. Oh, coffee is still hot. Very too hot. Gosh, this mem0 is like the most complicated mem0 I've ever written. It's ridiculous. I should verify that this p header is the interpreter's program header. Maybe that is the original binaries program headers, implying that we need to keep them mapped. Anyone? Hmm. I love to be reading the source code for the "you did not intend to run this program" message. I feel like I still need more information, but it's looking like maybe these do belong to the binary that we loaded originally and not the interpreter. Let's find some info in the kernel to support that or not. So we were just here. There's the load adder, which really seems like it's different from the interp load adder. P header versus AT base. Yeah. I think we really want to keep the mappings. Like we do the first load and then we keep the mappings. Don't be boring. Okay then. Tuco left. You see, you scared off the cat. Look what you did. I don't know how anyone could think this is boring. Like, this is the Linux kernel. Like the actual kernel. It's pretty exciting, right? This create elf tables thing in Linux is kind of like that function that I was just looking at in my code, the like create stack whatever. Let's see if we can find it again. I don't actually want to switch projects. Now Tuco wants my attention. Replace maps with new stack. Hey. Tuco. So the first part of this function has to run with the previous mappings still available. So if you're in exec, it needs to do something with the initial or the original argument and environment and name of the program. So it starts with all of that and builds this temporary stack buffer, which is where all of this stuff is going. And then once it has the temporary stack buffer, it does this unmap all user space mem and then stack finish. I guess I need to get the cat back on the screen. Go. Hmm. Hmm. It's cold. It's cold, Tuco. It's cold, and I don't know what order to do these operations in. Yeah, I mean, it seems like we're expected to have both sets of mappings present, the interpreter and the loaded program. I've just got this annoying dependency problem now that I've got to figure out how to break. Like, I need to know the contents of the aux vectors to build the new stack, and that happens kind of late in this process. Kind of early in the process, actually. Like, it's before we actually load the program headers. Time to leave the cat alone. Is that all, Took? It'd be good to find the actual source of documentation on this part of the process. I don't know if any of this is documented or if everybody just refers to the Linux and libc source code and some outdated spec. Tiny whiskers. Oh, that's a good cat icon. It's like distracting to everyone to have to hold the camera. That's not terrible. Aw. Yeah, this camera on the ground looking up at Tuco is kind of underrated. Should do this more often. Are we focusing right on the hairs in Tuco's ear? Camera's actually really close. I'm surprised it can focus as well as it is. Cat shoulders. Ah, what a good warm boy. Get all these little hairs all over. Oh yeah, that's a good point. Platypus mentions that there's a Twitter account at Tuco the Cat where I post plenty of pictures of this little guy. Oh gosh, sorry to hear that you had a migraine and you're not feeling well, but I'm glad the stream is helping out a little bit. Gosh, Tuco has such a warm, soft neck. He's sitting on top of one of these heated pads that he likes so much. So much hair. It's like the most awkward angle for me to brush him at. That is really the essence of being a cat. Is I want to brush him, but it's like awkward for my wrist. He will just sit in the most awkward location and just be as cute as possible and as calm as possible. Gotta get all those fuzzy hair bits out of his face. Tuco seems especially interested because I'm using his food bowl to prop up the camera. Hmm. He really likes those neck rubs. It's very soft. Hmm. I should revisit how Linux does this. Like, I think Linux's elf loader does basically just do a whole second pass once it detects there's an interp section. And it's seeming like I might end up needing to do basically that kind of thing too. It's just Linux's way of doing this has a lot of like 1,000-line functions. Oh, does Linux actually process the program headers twice? I could make the code bigger right now, but Tuco is just so good. I don't want to detract from that. Maybe we can squeeze them in side by side. Oh, cool. BTC Fly on Twitch chat says they're working on a Rust project. What are you working on? Something like that, maybe. Oh, cool, a trombone synthesizer. That sounds fun. Gosh, doing sound synthesis in Rust seems like a pretty cool area to explore. Okay, so this is Linux bin format elf, load elf binary. So this looks like we're scanning the program headers once just to find out if there's an interpreter. Oh, cool. OCD wants to try out NixOS on an ARM-based laptop in the near future. That seems kind of cool. Oh, Tuco, are you leaving? Do you want additional food? Let's try feeding the cat. Let's try feeding the cat and putting the camera on the tripod so I don't drop it. Or step on it. That would suck to just step on the camera because I left it on the floor. Hugo has been into these ridiculous little cat food packets lately. Yeah, he wants one of these. He likes the sound that they make when they come apart even. Oh, I know, honey. Yeah, you want this? You're gonna make a giant mess by pulling it all over the floor. Such a cat. I'm curious what the environment your trombone synthesizer runs in is. Like, is it like an embedded project? Like, does it run on hardware? Does it run on... Is it like a plug-in for an audio workstation? Kind of curious what the kids are doing these days. I feel like I would love to do more digital music experimentation, but I have not quite figured out what, I don't know, like what tools are interesting. Like I played around with Ableton a bunch a while ago, but I'm just currently having a hard time wanting to focus creative effort at proprietary software. It feels, I don't know, just a bit more forward-looking to do stuff that has an open implementation around it. So I saw some folks posting pretty cool title cycles jams on Diode Zone recently, and that has me maybe inspired to try something like that. Platypus says Ableton bad, LMMS good. I've never heard of LMMS. Is that like XMMS? Ah, I was hogging the coffee maker. That's how you keep the coffee maker full of the kind of coffee you want to make, is you just keep the coffee maker in your room. But it's kind of a dick move. Oh, cool. BTC says the trombone simulator is standalone right now, but they want it to be a plugin. And then Platypus says that the LMMS program is an audio workstation thing, but open source. Yeah, I'd like to look into that. I feel like I've been wanting to have more like open pluggable audio stuff in my setup and less annoying Ableton garbage. I don't even have a recent version of Ableton. I bought Ableton once a long time ago and I've just been using it, so it's currently pretty old. What does elf read actually read? Interp elf x. Oh, that's an elf header. What is elf header? Is that just the file header? Where's this actual struct elf header? Oh, it's the current bitness. So it's actually elf64 header. I haven't looked into how we load 32-bit elf binaries on 64-bit kernels yet, but that's also something I'm not really interested in supporting. Like 32-bit compatibility is actually extremely complicated, and I have practically no use for it. So it seems like something to omit. Oh, hardware synths connected to old computers also sound kind of fun. Is there not an ASM generic elf? This UAPI elf. Cool, so that's all exactly what you'd expect. Yeah, right now this is focused like exclusively on x86 64 Linux. I'd like to add ARM64 Linux in the somewhat near future, but it's still like this is mostly for media transcoding, and most people are going to be doing media transcoding either on a GPU or on an x86. Like software H.264 on ARM doesn't seem super likely on anybody's roadmap right now. Joe is wondering if 32-bit compatibility does any kind of weird packing of data, or does it just waste the top half of everything 64-bit aligned? So in general, the kernel interface is concerned with registers rather than memory. So like most things are dealing with 64-bit CPU registers, and so it's actually much easier for everyone to just use two 64-bit registers in place of two like any other size registers rather than trying to pack them together. But there are a bunch of ABI differences where you have structures in memory. There are a lot of cases where there are maybe two different structures for 64-bit or 32-bit, but there are maybe some other cases where there's one definition which just has to be implemented a little bit different for 64 or 32-bit. Like I think stat is like that. Yeah, there's some stuff like stat and time val where folks wanted 64-bit values for kind of forward compatibility purposes even before 64-bit registers were a common thing. But then, like most of what's going on isn't just the sizeness. Most of it is that the 64-bit binary interface is a different beast than the 32-bit binary interface. So, like, whereas the 32-bit interface is something that's had to maintain continuous backward compatibility since practically the very beginning of x86 at this point, 64-bit was a place where at the hardware level and at the OS level, a bunch of baggage could be dropped. So, like in general, if you look at the interface between the Linux kernel and the Linux user space, it's just a lot simpler for 64-bit than it is for 32-bit. And if you want to support both, there's a way to kind of pack 32-bit system calls into the natively 64-bit interface. But that's more about translating system call numbers and just having alternate implementations of system calls than just like shuffling the size of data in registers. .64-bit in general is just a good time for lots of folks to drop unnecessary backward compatibility and simplify things. This is such a weird comment. Load in elf-interp is more generalized than read? That's weird. So yeah, here interpreter is a file object in the kernel, so it's already been opened, but I don't think we've done anything with it. Like here, we're just making sure that it's immappable in the first place. Where are we getting the interp program headers? I always think phnum is phone number, not the number of program headers. Oh, Tuco, don't eat my headphone wire. Gosh. He always wants to chomp on wires right after he's eaten his actual food. It's like he wants to floss with them or something. Oh gosh. Tiger. Wombat likes seeing GoTo in this code. GoTo is very common in kernel code, yeah. I mean, it's pretty frustrating how obtuse a lot of the Linux code is. Like, if you look at this, this is what, like, over 1,000 lines in one function with a bunch of separate error exit paths. And you have to spend a huge amount of time just staring at this to convince yourself that it doesn't leak memory under most circumstances. Okay, yeah, that one function was 500 lines and has 3 different kind of go-to error handlers at the end. So, I mean, can you write code like that? Sure, but why would you? It is kind of frustrating. I used to find this kind of stuff much more defensible when compilers were worse, so like maybe some of this is older, but I mean, I'm sure this code is quite old, but still, it's frustrating to have to maintain stuff like this still. And like if you ever look for test cases, like there are tests in the Linux kernel, but not nearly as many as it seems like you'd need for code of this quality. Oh. Tuco is making such a mess. He likes to wander around, and he seems to always move right after I get the camera situated somewhere. Anyway, I was trying to figure out where that interp... Right, so interp elf pH data, where does that actually come from? So during this first scan of the program headers, we're saving elf interpreter, which is actually the file name. It looks like elf read is just a wrapper around read that probably has special error handling, but let's check that. Yes, it's just a wrapper around kernel read. Is this a copy of all the program headers? That's one thing that I don't currently do, is I don't actually copy all the program headers because that's a variable sized piece of data, and I've been really conservative with how much variable sized data I keep in my emulator. I've said this before, but Linux is definitely not an example of good code quality. It is an example of something that through huge amounts of effort and manual labor, folks have managed to make mostly work, but it's not good code quality by any stretch. See, that's a good question. Joe is wondering what a better alternative is in C to all these go-tos for handling cleanup cases without copying and pasting a bunch of deallocation code and making sure that you're actually cleaning up everything correctly. Yeah, so I mean, that's a great question, because like without the go-to, one way of doing this might be like every time you have one of these ret vals checking for the error condition, you figure out what at this point needs to be cleaned up, and you do the cleanup, and then you return. I would argue that the root problem here is that you're doing too much within one function or one scope, and there are features in other languages that make this significantly easier to break up. But even in plain old C, I would actually split this up into multiple functions and try to split them up at least so that the number of... Like, I think it's an anti-pattern for one function in a language without RAII types like C to have multiple resources that are allocated. Like, there should be one failure path in the function, maybe like two for like resources allocated or resources not allocated. But having multiple types of resource allocations that can all fail in a single function just seems like a problem. Like, if you're in that situation, you need some leverage, and you can get the leverage either by switching to a more powerful language or by adding some abstraction to your code itself. But like, you need a lever to give yourself more abstraction in that case, because this is just not maintainable. Like, I've written plenty of code like this because it didn't seem like there was a good alternative. But I feel like in those situations, it was because of limitations in the program's architecture as a whole, or in the compiler, or in something else that was weird about the environment. And like, I feel like nowadays there are vanishingly few excuses to write code like this. It's like, who's got time to keep track of which particular out labels actually clean up the right kind of resources for this particular case, especially in a function this big? Like, it is a recipe for problems. was going to look up this actual program header loader. Okay, so this will load up to 64K of program headers. Interesting. There's so much variable-sized stuff in the kernel that doesn't seem extremely necessary. It's always better to have your own local copy of something than to map something that user space might fuss with, though. But anyway, so I'm taking a different approach in my loader, and I'm reading the program headers as I need them, which also seems fine. I need to have both files open, and I need to keep the mappings from the main program as I'm loading the interp. Well, let's just start hacking on this. I think I've been staring at Linux code enough. To go. That other camera angle was pretty good. Gosh. Decameron says when they see exceptions, they realize why they like GoTo. I mean, I certainly wouldn't recommend using exceptions to solve this problem, no. GTS wonders if I miss Sublime text. Not really. I mean, sure. Decameron says, on a more serious note, what's with the cat, if that's okay to ask? What isn't with the cat? I'm not really sure what you want. It's a cat. His name's Tuco. He is pretty cool. He likes to fetch nylon bolts. He's pretty relaxing some of the time. It's tempting to just make something special purpose that just gets the interpreter, and then do that before most of the rest of this loading. Like I feel like I need to I need to be past the point where I'm reading the program headers of both the interpreter and the original binary before I do any of the stack construction. Oh yeah, I like the image quality on this camera too. This is like my new camera that I use for mostly electronics photography, but it's also really good at cat. And I don't really have a good way of getting angles this low, so I'm just setting it on the floor. I had that feeling of missing Sublime Text when I was trying to use Atom, but I feel like using Emacs does not make me miss Sublime Text. Using Sublime Text makes me miss Emacs. Vim plus cat equals Emacs. I mean, I think Vim plus Emacs is also Emacs. That's kind of what I'm using. Yeah, I've used like vanilla Emacs for a long time. I used that as like my main editor for years and years and years. And then I kind of got into trying stuff like Sublime Text, and I used Sublime Text for a while. I dabbled in Atom. I never really gave VS Code much of a try. But yeah, now I'm using Doom Emacs, which is pretty nice. I mean, I used Vim a little bit, and so the Vim key bindings in evil mode were not completely foreign to me, but I also just started to focus more the last couple years on trying to have keyboard habits that hurt my hands less, and so evil mode was part of that. Oh yeah, there's a good question about whether you need to return values in Rust or if it's just the last thing in the function. You can return, there is a return in Rust, but you can also, yeah, like if it's a function, like the last statement in the function, the return value. It's actually more general than that, though. Anytime you have a block of code, the last statement in that block of code is the value of that entire block. So you can use that in some other interesting ways, too. And part of the reason for that in Rust is that, oh, I need to go. Part of the reason is like you end up wanting to kind of thread values through like ifs and loops maybe more often than in other languages in order to keep like satisfy borrow checking rules on those values. That's not what you want. That's better. Platypus says they miss Visual Studio style autocomplete. So that's funny. I've never really liked autocomplete in editors, but they, like, if you install Doom Emacs or many other fairly modern distros of Emacs or Vim, you'll probably have like language server support for your favorite language. So that's how I'm getting like Clippy, and I don't usually like completions, but I like having errors and warnings in the code. I mostly like an editor that lets me type and gets out of the way and doesn't try to type for me. Do you want that open, Took? Tuco. How far into this am I assuming there's only one file I'm reading? Because that's going to be a problem. Like this loader read file stuff. Tuco's got company outside. Hey, Tuco. Hey, Tuc. It's so cold. Yeah, the thing where you start to type and it lists a drop down of commands, I don't actually like that, but I know a lot of people do. I think you can do that with Emacs, I just don't actually care. That's interesting. Do I want multiple loader instances, maybe? I don't think so. Like, each loader is intended to have the sole mutable reference to a stopped task. This definitely needs refactoring, though. Like, this doesn't really fit into the situation I currently have. Like, file name, and file header would all be separate for the interp and the main binary, whereas argv, envp, and the trampoline are for the entire load process. trying to remember why we even need this file name string. I think we use that for the exec file name aux vector. Yeah. In both cases, this is something that was originally a string in user space, but for the main binary, that's a string that came in from before the system call, and then at some point during the system call, we unmap that string. For the interp, it's something that was in the program header somewhere, and we've got to load it into probably the stack. I feel like that and the argv and the env should just be part of some kind of loader args that are all dependent on the previous address space contents. Alright, I guess the next change I'm shooting for is some refactoring of the loader. Oh, I'm also not sure if trampoline should be in here at all. I don't think it should be. So there are several of these kind of optional layers that you might need in order to do some operation on the remote process. You might need a trampoline, which is information about a system call instruction you can use to re-enter the kernel. You might need a scratch pad, which is a single page of memory that we can write to. You might need a temporary file. You might need a specifically zeroed temporary file. So there are these various things that you can create, and the particular combination of them will depend on what you're doing. And I've been trying to make their creation and destruction fairly explicit, because I want them to be shareable between multiple operations, and I also want the higher level code to be aware of which of these temporary objects it's creating and when, for the most part. So I've been trying not to hide these too much. So something like map file, maybe instead of creating the scratch pad here, I actually want to take it as a parameter. This also means I can have fewer lifetime parameters everywhere. this object basically just becomes a file and a file header, which isn't very much, but maybe it's actually useful to just hang some interfaces off of that. When I originally wrote this file, I was thinking that the loaders would want to have maybe a simpler and maybe more stable interface to the rest of the system than, I don't know, stuff like Scratchpad and Trampoline usually have. But now I'm kind of coming around to feeling like those other interfaces are stabilizing a bit, and I'm not sure I can do everything I need in the loader without having a little bit more freedom to like open multiple files. It does seem like passing around this combination of things and also having a drop implementation are both pretty worthwhile. I hate how these are called binaries because, yeah, of course the file has binary data in it. What else would it have? Octal data? But I mean, it's also an executable. But then again, like, a lot of people wouldn't call LDSO an executable, even though it is. So I don't know. A binary executable. I mean, it's funny though, because like script files end up on this path too. So like if I'm running a shell script, it would turn into a binary file if that's what I name this. So this is not totally dissimilar from wrappers like temp file. Maybe I basically just dissolve this module entirely. Right, like I was trying to keep knowledge of all the scratchpad stuff out of the elf code, but that also means that I'm doing a lot of unnecessary mmap, munmap, mmap, unmap. Not that that really matters, but I'm just thinking about how to re-architect this a little bit. Yeah, so this is just like a wrapper around stuff that's already in the stack builder. This should be on task data probably. I need some kind of tiny tripod situation. One thing I would do with the magic arm sometimes is kind of drop the camera from above, so I'd have that clamped onto something above, and then I'd have the camera mounted upside down and get pretty close to the ground. Oh gosh, bodies are complicated. I feel like I'm always having trouble with stomach upset in the mornings. The thing I want is very similar to that data structure. So maybe I call this like vexec. I don't like how untyped these are. Oh, maybe I should make that struct public. Alright, so stopped task is all we've got when this process begins, but like, but is it though? Pretty much immediately we're gonna have a trampoline. So we need to read that file. Oh wait, no, that's a local file, so we don't need the trampoline to read it. And opening the file takes an IPC call, which only needs a task. It doesn't even need a stopped task. And this doesn't even make the trampoline until the very end. Right, I'm thinking exec args and file header go into bin format. Read string array. That's all part of remote mem. Good cat. It does seem like I want a struct that combines file, file header, and exec. Not really sure what to call that though. I could call it bin format exec. Oh yeah, good question from Twitch chat. They're wondering if there are past videos and if this is on GitHub. Yes, on both. Here's the project on GitHub, scanlime/bandsocks. And Past videos are on Twitch and YouTube and Diode Zone. If you go to... Actually, I need to fix this. It's actually kind of hard to find the scanlime-in-progress channel here. But yeah, all the recent streams are here on Diode Zone. There's also Twitch. I don't know, usually it shows you past streams, past videos, but I think right now because I'm streaming, I don't know if it'll do that. But yeah, all the archives are here in Diode Zone. Oh yeah, the videos do not stay on Twitch forever. Only the last couple will be on Twitch, but all the videos are on Diode Zone, and they're all on YouTube. I just want to call this like exec with file or something, but this does not seem like a good abstraction boundary. There's another question, how long have I been programming in Rust? Not that long. I mean, I feel like I've tried Rust like off and on for several years at this point, but this is my biggest project in Rust so far, and I've only been doing this for a couple months. And the follow-up question is, do I like Rust? Yeah, actually I like Rust a lot. I mean, I feel like computers in general are kind of hard to like at this point, but Rust feels like a relatively bright spot in that dismal array of things. I feel like it's this nice combination of kind of empowering for people and also technically empowering that I appreciate. And I like the community. I like the borrow checker. I like doing things at compile time. I like async. I like being able to use the same language for systems that are fairly large and fairly small. So yeah, I feel like there's a lot to like about Rust. I don't really like this name, but it's the best I've come up with so far. File. That's a nolibc file, isn't it? I have no loader. Stop task. How's that know where a stop task is? Process task, I guess. This is a weird part of the program. because of how, like, what kind of program this is. Like, it's an emulator, so there's like multiple kinds of open. There's like a real open, there's an emulated open, there's the inter-process communication channel that we use to emulate the open. Like, this is one of those cases where the process in the sandbox, the one that we're emulating system calls for, does not actually need the file descriptor, but we're opening it on behalf of the exec. So we need to have the file descriptor and in the emulator process, but we don't actually need to pass it all the way through. And I don't think we need the stat info for this file. So like this v file is the virtual file system inode that we would use to get stat data and other metadata for the file. I think we can just ignore that. But like nolibc has this very thin file abstraction here, but the open is actually just for opening files locally, which isn't usually what we want. So like notice this will fail after the setcomp policy is installed, which is most of the program. Good chill cat. Maybe this should include the file also, and it should be file with header. This doesn't even need to take a stopped task. This just needs a regular old task. There's a question about what the editor is. This is DoMeMax. That's the macro that we're invoking, this IPC call. I think that needs to be mutable reference to the task. Oh, A2 go. This time it does need to be a stopped task. Do not want to load when the task is not stopped. Huh, there's a question about a new module file naming convention instead of mod.rs. I have not heard about that. How new is this? Oh, this. Hmm. Yeah, I'm kind of with this person. I didn't realize this was supported, but it doesn't seem right to me. All right. I mean, I generally try not to keep very much in the sort of root of the module anyway. But in this case, that's where I'm writing this code. I might move it, but that's where it is right at the moment. Anyway, I'll be right back. Maybe Tuco will stay here for a sec. Actually, while I'm gone, I should put the GitHub back up, just in case people haven't seen the URL for that. Be right back. Brr. Good cat. I don't understand what's going on with this mod.rs conversation. Where is the obligation to create a directory? That doesn't seem like it was part of either system. Yeah, I think one of us must be misunderstanding this module system because like you've always had the choice of like where to put the code. You can always, like, Rust has a very flexible module system. You can put things in subdirectories, you can not put things in subdirectories, you can put everything in one file, you can split up your files. And like, yeah, I mean, as folks are pointing out, like mod.rs could be replaced by a file with the same name as the directory, one level up, but that like presumably if you have a directory it's so that you can have multiple submodules, and so I don't really see how this is extremely relevant. Like, if you want a directory, have a directory. If you don't want a directory, don't have a directory. Nobody's forcing you to do anything here. Okay. Oh, Tuco. Oh, that is the worst angle to hold my arm at. Hey, Tuco. Good cat. Yes, that's the lens, Tuco. Oh, Duke. Cat and sock cam. Do you want that coldness again, Tuke? We could try actually going outside, but I don't think he wants that. He seems to just want to look outside and then go back to where it's warm. That needs a task and a path. Yeah. I usually make the stop task the first argument, even if that's the opposite of what this function is taking, because it's got a self parameter. Well, that seems better. What's the first other file I should update now? See, we need to change the signatures in the loader. We need to change a bunch of stuff in the elf loader. Then there's the script loader. Where is IPC call? Doesn't seem like I should need to import that separately. This doesn't actually need to consume the struct for like memory efficiency reasons, but none of these values are going to be usable after load, because these are pointers in the remote address space, and if this is successful, or even if it isn't, the remote address space might end up being destroyed. I wanted to start out by replacing this with a stub and make the rest of the program compile. Maybe this is about the import order. So if I remember right, Rust, like most of Rust, allows you to make forward references and it resolves symbols somewhat late in parsing, but I don't think macros work the same way. I think macros depend on the order you actually include modules in, so maybe that's the problem. So this is in bin format mod. The other one was process mod. Let's try moving bin format down. I don't know if that's it, but I guess that wasn't it. Oh, do I not have a macro use because I'm only using IPC call inside of process? Oh, that's the thing. Maybe I want to move IPC call up. Or maybe I do just want a macro use. Yeah, let's just macro use. Okay, here's the actual exec entry point that needs updating. Do we just need exec? That would be nice. Have a single entry point for that. Okay. That's a little nicer. This might compile. It definitely won't actually be useful, but... Oh, look, it doesn't even compile. Oh. Oh. This has to be async to do an IPC call. Yeah, Tuco is really into these little heated blankets. I found this kind that, I mean, you can find various kinds of heated pads. This one is specifically for pets, and I like it because it's low voltage, so even if Tuco manages to chew through the wires, it's not as hazardous as 120 volts. But it's also, like, it already comes with basically the same kind of cat protection. It's got, like, crinkly tubing over the wires, so it seems like it already had that in mind. Okay, is this all dead code? That's fine. Lots of code not being run at all when the loader is disabled. So if we actually try to run a binary, it should just always fail with a format not recognized or something. All right. And welcome to the stream if you're just dropping in. I'm working on this kind of Rust sandbox project called Bandsocks. Right now I'm mostly just kind of doing some cleanup, changing some of the interfaces in the binary format loader so that I can implement elf interpreters. I ran into a problem with some of the intermediate code in this stack, assuming that there's only one file going into loading a binary. And with elf interpreters, that's no longer true. So I need to split this up a little bit. Yeah, so a bunch of tests failed, but it actually compiles now. Yeah, I couldn't do this without testing. Having unit tests and integration tests, very important for making a sandbox. Really most like operating systems level stuff where there are just so many different things that can go wrong. Right, it seems like I should make this slightly less flat and maybe have a data type representing a loaded elf binary specifically. Maybe I'll make this a tuple struct. I want to call this elf header, and the other one program header. It's also really unnecessary to namespace things elf64 when that's what this entire file is about. Do we have focus? If I can focus the camera without looking at the screen. I could actually take this opportunity to name these in such a way that they indicate how much work is being done. Like get elf header versus read program header. I kind of feel like this copy, like this is actually making a copy of the elf header instead of just referencing it. Which I'm not too fussed about, but I kind of want to keep it around at least so I don't keep remaking it. Part of me really wants to alias those values, and part of me really doesn't. If there's a question about what font this is, actually I have no idea. I don't actually know anything about changing fonts in Emacs. I mean, I don't super need to copy this. The data is read-only and it's aligned. It seems like I should be able to alias it. Why is this... Why do I not have to clone this explicitly? Is this data type copy? Good old goblin docs. Why is this copy? Why is this derive copy? Why would you do that? Derive copy is supposed to be for data types that are approximately free to copy, like pointers and integers. Putting derive copy on an entire elf header just seems ridiculous. Why? So that's why we were getting a copy of it without even noticing. The only reason to use this goblin library right now is for some of these type definitions, and even the type definitions are not amazing as far as I can tell, but I'm still using it. Copy. Gosh. So let's not store the header. This is intentionally just reading a single block, so this could be truncated and filled with zeros. Am I fighting the autofocus here? Aw. Manual focus time. I think this turns into pread exact. That's a nolibc file inside. Yeah, pread exact. Okay, I feel like the next step might be looking for the interpreter, because what does loadouter actually need? I mean, that definitely needs a different path when we're on the interpreter. I kind of want to fix my mess, though, and make sure that things work before adding new features. So first I'm just going to do the refactoring part of this, and then I'll do the interpreter part. Right, like some of this stuff can definitely move to the elf. Like I feel like loadouter probably will not exist for that much longer. Like this especially. Yeah. This part's a little fiddly. Oh, what a good cat. Yeah, I've done like even less customizing on the graphical front end for Emacs than like the rest of Emacs, because I'm 90% of the time using Emacs in a terminal emulator. So like stuff like I don't know, like this blue bar on the left that shows what I've edited, that's great. Usually it shows up as text, like colored equal signs and stuff. Similar with the stuff on the bottom is usually rendered as text, so I'm not quite used to seeing it graphically still. Man, I like the borrow checker. See, like this would be very fiddly to do in C, but here, like in Rust, I can keep a borrowed reference to this E header, which is part of self, and then use a different part of self over here for period exact. I think that'll work just fine. So here, I think I'm going to have multiple immutable references to the same header, which I think is going to work out fine. I think user space regs there just gives me a mutable reference into the stopped task. Yeah. I don't really know where that should live, the init registers. I feel like this should stay simple and just take an entry point and a stack pointer. Stretch. Oops. Okay, 2 functions left in this file, but they're kind of complicated ones. Also got some problems up here to fix. There is no more loader. There's no load adder. It's really tempting to just go right for adding the interp here and not try to do it piece by piece. Yeah, let's just make a big mess here. Hmm. I think I just use the scratch pad. Like, I don't think anybody super cares about having a string pointer to the interpreter file name afterwards. I feel like I could read that string into my scratchpad memory, which is just like one page that I have. Oh yeah, actually no, that's bad for multiple reasons. So like I don't even want to have to, like, I'm sure it's not a big deal to enforce path max and ensure that paths are not bigger than a page, but it would just be nice if I don't have to care how large the paths are. And I'm not actually going to be interpreting the path here. The virtual file system is in a different process. So I think at this point I would just want to open the file, and then once I've opened the file, no one cares about having a valid string. Is the cat alive? Yes, he's just sleepy. Welcome to folks who are just joining the stream. This is mostly just a chill kind of Rust programming, co-working kind of stream. I'm working on this sandbox environment that's intended to be a pretty simple way to load like FFmpeg or other sort of computational workloads inside of an existing network server. Gosh, cat fingers. Cats have great fingers. I think this means I need to temporarily mmap the interp section, though. Okay, let's start with this loop. So we're doing something very similar. So we need the E header. We need to loop over the program headers. This time, if it's an interp, I don't know if I care about cleaning up this memory mapping at this point because the entire process is about to be replaced. I was thinking about whether this needs to return some kind of type that can track the lifetime of this memory mapping, but I don't even think it does. Map interp file name. This would be the actual option vstring. And because this is dealing with the remote process, this does need a stopped task. So the actual project here is it's like a sandbox runtime. Let me pull it up in GitHub. I almost got coffee last time I was up, and then I kind of thought better of it because I figured it would just make my stomach upset again. But now I feel like I should just get some coffee and take the chances. I'll be right back. Ah, Tuco's still in place. Almost like he's cozy or something. I'm trying to make some coffee and a small snack, but I don't want to leave you totally hanging. Gosh, what a pretty cat. It's not actually that cold in here, but it feels pretty cold. Okay, so read interp pheader. Gosh, I got up so early today. I don't even know why. map file. Gosh, I know you probably don't need to hear me chew. I'll try to mute that next time I take a bite. So the previous implementation here would send the file descriptor every time it did an mmap, which was not incorrect, but a little bit wasteful. There's not really a good reason not to do that, but it would be nice to, I mean, it feels cleaner to maybe have a way to keep track of the remote file descriptor also. Cleanup code for all of this gets kind of annoying pretty quickly because there are several of these objects that don't automatically clean themselves up, like the scratch pad and the sent files. And that's mostly because these things have asynchronous cleanup. Hey, Tuco. Oh, it's Tuco leaving us. Tuco wandered off. There must be a better way to avoid proliferating lifetime parameters like this. Can I really not elide these? I feel like I probably can't, but maybe I'll try and see what the compiler says. Okay, let's start with this. Oops. Thinking about whether to put the sent fd in the elf file or not. Slight collision between the microphone and the hummus. Yeah, maybe this needs to be a pair of files. So now I'm wondering if this should actually be part of exec file. Oh, Tuko, what are you doing? Honey, what are you doing? He was just like scooting his butt across the floor. I don't see anything immediately wrong, but it looks like he must be irritated. To go. Cats are so weird. He wants the door open again. Oh, cat. Oh, I forgot to turn the mic on after that point. Sorry. I was trying to mute myself while I took a bite of the hummus, and then I forgot to turn it back on. Thanks for telling me. Got another question about what I'm working on. This is just sort of a chill Rust coding stream. This particular project is part of a sandbox runtime I'm working on. It's sort of designed to be a simple way of running FFmpeg or whatever computational workload inside of a like sort of Rust network daemon that you've already got going. Okay, so this elf file thing, I think I always want this to have a local and a remote part though. Let's start with an exec file. I guess a stopped task. Oh, Tuco's food is right over here. Brr. Tuco seems upset that I closed the door already. Now I'm just thinking about the lifetime of stuff like the scratch pad and the trampoline. The trampoline could live for the entire duration of the exec. The trampoline depends on the kernel VDSO section, or VDSO mapping, which we don't mess with. The scratch pad, on the other hand, is just an anonymous mmap. And at some point during the loading, we delete all the mappings other than the couple that we're actually using. So that code would need to know about any scratch pads that we're not planning on deleting. I think Tuco's just gone for the moment. Where do we delete all the mappings? That is right down here. Loader, unmap all user space mem. Loader is not a thing anymore, but what did that used to do? That was a call on the trampoline. I think we just ditched the scratch pad before we get to that point. I could make a version of this method for the scratch pad that unmaps everything except for the scratch pad mapping. I don't super like that, though. Oh, I was doing better when we had a cat on the stream, but I think we'll manage to survive without a cat if we have to. I mean, Tuco's just down the hall, I assume, but... Tuco is super cute. Oh, is he back? Oh, Tuco. Tuco. You already asking about the door. Nobody told him to hold still. Oh, back to the heated shelf. I need to like 3D print an additional tripod shoe for this, and then stick that on the bottom of the dolly so I can just keep the tripod near ground level easily, or keep the camera near ground level easily. Just moving that back and forth gets a little old. I have one of those tiny tripods somewhere, but it's probably not strong enough to hold this camera. Yeah. Tuco is concerned. Tuco. That's right, this doesn't actually need the scratch pad. Linux kind of had this layer right above mmap to handle the page alignment, and that seems like kind of a good idea, doesn't it? The folks trying to give me editor tips asynchronously in the chat, I don't think that's going to work, but... Yeah, I don't know. This case feels different enough from load segment that maybe I'll have them both just use mmap directly. Some of these calculations are going to be similar, though. Kind of want a separate data type for these aligned program headers. was thinking about changing that, but I'm mostly happy with the names. I just want these all bundled together into a new type. Having second thoughts about making this a struct versus having a bunch of accessors for a raw program header, but I suspect they compile into approximately the same code, and this feels a little nicer to read. I really don't like this. Part of me just wants to stop using this goblin library and define my own elf types, but that's probably not actually good. Like, I could just have a straightforward kind of wrapper or a trait or something on program header that adds some additional methods. No. That's better. This feels like an intrinsically messy piece of code. I'm thinking about ways to change the interface to be cleaner. But like the thing that I'm intrinsically doing here is trying to deal with the mismatch between a memory management subsystem that works with pages and a file format that doesn't necessarily have page-aligned segments. This is a little bit longer, but we're not relying on the optimizer to remove unnecessary calculations this time. Where is there a lifetime reference in there? I wonder if that's an old error. String is the beginning of the segment, so I don't need to add another offset. String. Where did I put those files? Oh, remote. That's a good question. Do I like Rust over C++? Yeah, over or under or next to, instead of. Those are all great. I mean, there are still plenty of applications where, you know, like if you're using a big C++ library, it's often, you know, easier to write your thing in C++ instead of having a bunch of interfacing between the C++ thing and the not C++ thing. But I mean, even I feel like C++ binary interfaces are not extremely common, especially compared to C language binary interfaces. And if you have something that's designed for a C interface, then you can generally use it in Rust or use Rust in it without paying any kind of bridging penalty. But then when you get into C++, it's just more complicated. Like generating compatible Rust code is not always possible with C++, like it's sometimes possible. C++ is just more complicated and doesn't map, or doesn't have, you know, doesn't have like a stable sort of C-style interface for everything. But generally people try to keep to the C-style parts of it when they're designing libraries. Cat stream. Oh, map interp file name needs to be async. Oops, sorry. Tuco's so much bigger than me with this camera. too, go. Oh, you want to do this again? Now he's just sitting next to the door and cleaning himself. Hummus cam. You too, go. Tuco's in an inconvenient spot. Cleaning mode. Oh. Gosh, I liked the idea of doing a really long stream today, but I'm already feeling like I'm having trouble with energy. Hummus cam. Hey. Hey, Tuco. Wow. Ah, Tuco, you're such a baby. Oh yeah, there's some surprise about having async functions in Rust. Yes, Rust has async, and it's actually really good async. Like, Rust is, like, one of the things I really like about Rust is that it's a very versatile language. You can use it to write very high level and very low level code and a lot of stuff in between. And async is like that also. You can write really high level network async code, write web servers or whatever. But you can also use async in really constrained embedded environments. And I'm kind of doing a little bit of each here. I'm using async in the higher level network code in the sandbox, and I'm also using async in the really low level system call emulation code. That code is user space, but it acts like kernel space code in a lot of ways. Tuco. He's so interested in that. Yeah, Rust async functions are pretty cool. The compiler will just statically analyze them and turn them into state machines. And then you can deal with that resulting state machine in whatever way you want as a Rust object. Like, it can live on the stack, you can dynamically allocate it, you can have little temporary state machines. The way I'm using async in the low-level parts of this, each process running in the emulator effectively gets compiled into just a single async task, and then I run a bunch of those, one for each process. I can't name the type of the result object yet. You mean for async functions? That's true of closures in general. Like async or synchronous closures result in opaque types. But you can usually just use generics and you don't have to name the type. Can't computer without getting in the way of the cat here. Maybe I should just eat my hummus. Also without getting in the way of the cat. Tuco, what did you find? Tuco is very interested. Also, it's cold. Also, I'm in the way. Gosh, there's so much green light on this door. Lots of interesting smells and sounds outside right now. Alright, it's cold, but we can see the cat, and I can kind of use the computer. Mappable segment. Merry Christmas. Yeah. Yeah, Merry Christmas for folks who are into that. Over here it's mostly a day. Just a sec. Oh. That was my housemate offering me some food. It was very nice of them. Why am I not celebrating Christmas? I don't know. Why should I? It's just not really something I do. I mostly just find the holidays super stressful, and it'll be cool when they're over. Winter is kind of nice, but I also don't really like being cold. And I feel like the winter holidays are mostly lost on me. Like, it's all this like traditional community, like getting past the darkest months of the year and all that. And I mostly just feel like all the rituals make all that stuff even worse for me. So like, I don't especially like Christmas. If I'm feeling cold, why don't I go inside my house? I am inside. I mean, I could close the door, but then the cat wouldn't be happy. The cat being happy is the most important part of this. I've got some lukewarm coffee. And some probably not warm anymore hummus. Now, my intention here was mostly just to show up and write some code and hang out with the cat and all of you. Oh, where do I live? Oh, now it's getting personal. I live in the world. The California part of the world. It's not extremely cold here, but it's slightly cold. But really, you should want to know where the cat lives. Isn't that more important than me? Gosh, I kind of feel like this should just be segment, and it can have a reference to program header or whatever. Oh, Tuco's definitely found some good birds out there. Oh, yeah. Hira Katora says it's really annoying that you can't use a function as its own type. That's interesting. I feel like in general, yeah, like function traits and function types are a little bit weird. Like, if you want a type for any function with a particular signature, that is fairly straightforward. But if you want a type for a specific function, that's a thing that you can't write. I mean, if it's a regular function, I think you can write the type. But if it's a closure, or if it's an async closure especially, then you can't. I'm just going to get more hummus on the microphone at this rate. Sorry. Katora says that a fun arrow T, like a function pointer, is even weirder. It's a static reference. It's called a function pointer, and then the pointee doesn't even exist in the type system. Yeah, that is pretty weird. Oh, Tuco, why do you like the cold so much? You can tell it's not snowing outside, maybe, but like it isn't that far above freezing. Thinking about whether to move this mmap wrapper up into segment. It could be cool to have a single way to mmap a segment, and then maybe I have a parameter that tells it whether I want a fixed mapping or not. This also could be a good time to wrap up the stream and take up my housemate on their food offer and finish my hummus. Ah. Tuco. Can I close that a little bit, honey? It's like a not really. Alright, alright. I guess I could just have that take an option v pointer. Well, except that's not what I want. I want to either map it at an arbitrary address or at the specific address that the program header says, plus the page rounding adjustment. Yeah, I think I just need a little enum type for this. reevaluating which of these should be usize and which should be vpointer. Oh yeah, there's a question in chat about what I'm working on, which I haven't mentioned in a minute. It's a little Rust project that's designed to be a simple container sandbox. So this portion specifically is kind of deep in the elf loader. I was working on giving it support for elf interpreters, like LDSO, and that isn't that complicated of a change itself, but the dependencies got complicated. Mostly that I need the loader code to be able to handle multiple files open at once, because some of this stuff needs to refer to the loader or the interpreter, and some of it needs to refer to the actual binary we're loading. Brr. I feel like vadder can just be a vpointer type. Sizes and offsets are not adders, but this is an adder. Adding a vpointer to an offset is pretty common. I don't know if I want to actually make a method for subtracting, because usually that's not a good idea, but in this case it is. Okay, the adder aligned. Oh. I wonder if this mmap wrapper should actually handle the deal with file size being smaller than mem size. So when that's the case, what we actually want to do is map the first part of it to the file and then the rest of it to zeros. I had some specific code to do that when we're loading segments, but it seems like that should be more general. I think I can just always give this a remote file descriptor and it'll just ignore it from memory-only mappings, and that'll be fine. I'm gonna, instead of calling this segment.mmap, this will be segment.load, since it's actually doing more than one mmap. So we need self, trampoline, location. That all seems fine. Map anonymous. I don't know what Tuco's so interested in. No replace. I think I used that no replace flag just for precaution's sake. Like, it should always be writing to unused memory. But if somehow it isn't, then it'll fail. This is kind of annoying because if we're doing an arbitrary map location, then whatever the first mapping is decides that location, and then I don't like this no replace wrapper. kind of feel like maybe the segment struct should either be relocatable or somehow add an arbitrary address. Like the three cases that I'm thinking about here are a segment loaded at a fixed address, which is not actually super common these days, but is the simplest case, or a segment loaded at a relocated address. So in that case, we have a calculated address that we want to put it at, but there's an offset between that calculated address and the address that's actually written in the program header. That's a very common case, which is what the code I removed was handling. And then we have this new case where I actually don't care where it's loaded. I just want it loaded somewhere. Which right now I'm implementing that for this thing that I haven't actually written yet that gets the name of the interpreter out of the that segment. But there's also a case that I haven't really chosen to handle where if I'm loading a relocatable binary, instead of choosing the load address in this code, I can let the kernel choose the load address by not passing map fixed to mmap. So I'm so far not doing that because it was inconvenient to do the way I implemented this, but I'd like to be able to support that. So it does seem like this segment needs some notion of relocating itself or having an optional like dynamic address. Oh gosh. Well, I think I probably need a break from this. My body is feeling kind of cranky, and this is probably as much as I can just like sit in one spot and stare at the computer. But I'll try to keep doing these streams pretty regularly. I know it's not always the most interesting thing for everybody, but it seems like it's always at least kind of interesting for somebody, so I'll try to keep that in mind. And I'm sure Tuco always helps. The more I can just put him on stream. Yeah, just to back up a sec, since I've been like really in the weeds on this. Let's see if we can just run an example here. So this is normally a library, so you would embed it into other applications, but for testing I've got a command line interface also. So that was a very simple example. Gave it a Docker compatible image name, and it pulls it into a cache and runs hello. Yeah, and so right now this hello world that worked correctly was a statically linked position-independent binary, whereas this FFMpeg is dynamically linked. And so normally the kernel would be running the dynamic linker instead of running this binary directly. Because I haven't implemented that, the kernel tries to run this binary directly, and it ends up jumping to a non-relocated pointer, which crashes it. But let's look at the parts. If I run that with an empty cache directory, we can also see that it's pretty easy to find the specific part representing the binary we're running. And then we can run readelf on that. And this is what we were actually trying to load, this interp string. So at some point during loading this program, fairly early on, I need to read this section, get this string all the way up into the virtual file system where I can call open on it. And then, assuming that's actually also a valid binary, I need to assemble the initial state of the program using some information from the interpreter and some information from the original binary. Mostly the interpreter state, but it looks like I need to at least have program headers in memory for the original binary in order to put those in the aux vector. And yeah, I think we're getting to the point of actually loading these libraries, which is pretty cool. I showed a bit of that earlier on the stream, but if I manually specify the dynamic library interpreter, I can get FFmpeg significantly further into startup, and it's crashing on what seems to be pthread initialization using some system calls that I don't support yet. Well, thanks for stopping by. I'll try to do another stream pretty shortly, but let me know what you think. If you want more Rust, less Rust, more cat, something else, let me know what you're into. And I'll just keep trying to bring you these fairly regularly. And a special thanks to everyone who contributes on Patreon, helping me pay the electric bill and keep this place somewhat warm. So thanks a lot. I'll see you all next time. If you aren't already subscribed, you can get notifications for these streams in a couple of ways. There's the Twitch channel, so twitch.tv scanlime. You can also get notifications from YouTube, scanlime-in-progress. There's also a main Scanlime channel, but it's been for these edited videos that I haven't been releasing very often lately. So the new stuff is mostly on the Scanlime-in-progress on YouTube. And then I've also got a Twitter bot. Too cold to type. So yeah, this little bot announces stuff. It'll just take a couple of screenshots during the stream and also announce the beginning when it starts. So thanks a lot, everybody. We'll see you next time.